My name is Priyanka, and I'm the author for this presentation. This presentation is in part completion of the data science track offered by ABEX, and the presentation discusses wine, its quality, and physiochemical tests that were conducted for 1,599 samples of wine. The presentation follows the following format. It talks a little bit about the author, the data set. It introduces various descriptions of the data set. It attempts to crystallize on questions that the data set can possibly offer answers to. Attached code files and the approach discussed in this presentation will walk you through how the analysis was done. The presentation will contain visualizations, and we will have findings based on those visualizations, which will hopefully offer insight into wine and wine quality. A little bit about the author. My name is Priyanka Sharma, and post my MBA in finance, I carry about 12 plus actually years of work experience. My work experience extensively was with the financial markets and advisory roles to C-suite executives on all primary asset classes, namely equity, debt, and commodity. On the commodity side, which dominates my experience from the financial markets, it covers both physical and exchange traded derivative forms. Stemming from the advisory role is also communication. I carry a fair amount of experience in drafting business communique that is rooted in analytics. That said, I'm very new to modern day analytics and programming as such. Regarding the data set of wine, my experience and interest in wine so far has been limited to social occasions. That being the basis, the various column heads that the data set entails, as many of them are names in from the chemistry world, which I possibly have little or no background into. But the interesting thing about modern day data science approach is that during analysis at some stage we are able to disconnect ourselves from the column heads and understand the observations and readings under those column heads as numbers and proceed further. So that being the base, let's explore this data set, which talks about wine and physiochemicals that go into wine. The data set as such belonging to a food and beverage domain offered by Apex and discusses wine. It says that there were 1,599 samples, possibly from different bottles of wine, that were tested for 11 physiochemicals. These are being referred to as input variables. Each of the samples was then given a score ranging from 0 to 10. When we analyze, we are using the Python software and its entail libraries. As an author, I make no claims on the authenticity, source, or the validity of the observations. But that said, if it is 1,599 observations of recorded for wine samples, it should offer interesting insights into the world of wine. So let's dive in. Stemming from the previous slide, like we said, 1,599 samples were tested and recordings were made for 11 categories or input variables. These input variables have been listed on the left-hand side of the slide, starting from fixed acidity, volatility, volatile acidity, citric acid, right down to alcohol. And then, of course, each observation, each sample was given a quality score that ranged from 0 to 10. On the right hand side of the screen is again a description of the data set, and it is the description as understood by Python. It basically goes on to say that these are just numbers against column heads. These column heads have then been put against the yardstick of statistics, and using the concept of central tendency and mean median mode, we can have the mean, standard deviation, and median range of values for each of the variables that was tested as a part of the physicochemical test of wine for each of the samples. At this stage, we can possibly say that the fixed acidity, for example, had a mean of 8.3 and a standard deviation of 1.7. Compare that to the mean of volatile acid. The standard deviation was 1.17, which possibly goes to say that the standard deviation or the spread of observations for the column head volatile acidity was smaller than the spread of observations for fixed acid. That said, it appoints or gives little information about quality, and which is why it requires further analysis. At this stage, it's possibly a good stage to crystallize on the questions that we choose to explore. And really the first question was that, is this data set available to us in a format which is comprehensible to the human eye? Once we have a data set that is comprehensible to the human eye, and since quality has been understood as the key variable, how many samples made it to what quality score is what would be the first attempt. If we make assumptions regarding quality score, then what percentage of samples qualified for what score of quality? We would try to discover correlations between the variables, and we would also try to discover correlation between the input variables versus the quality score. We have identified certain key input variables, and these are density, alcohol, and sugar, and we will have an explicit discussion on how density, alcohol, and sugar go to impact the quality of wine. That said, as we mentioned earlier, the column heads can be some very complicated chemical language, and can these be converted into common everyday English language parlance? Hopefully that will offer us insights into wine and what goes into wine as such. It would be interesting to note how these parameters change, or how change in these parameters affect quality scores. And finally, we would try to present a profile of wine at each score of quality. This graph technically, or this slide, essentially is the largest takeaway from this presentation. And other than the usual suspects of data science, which is to check for missing values and identifying a key variable, in our case it is quality, there is going to be a discussion which can be classified as univariate, bivariate, and multivariate. The bullet point which says normalization and crystallization, which is important, I think by far has a very large impact on the entire conversation and presentation here. There are significant observations, which will basically be observations across all variables put together. And we will finally try to map the quality or wine quality for various quality scores against the input variables. Now, interestingly, when we work with data, it is required as part of exercise to keep changing the name, which I think is a very important exercise that we conduct. So when I first imported the data set into the Python environment, it was essentially a bunch of numbers with some headings. It made little or no sense. And these little smaller pink boxes that we see are the names of the data set that have been used for analysis. These names would be useful when we try to read the code files that have been submitted as part of submission here. The interesting part is that the first time we imported data set, it was really not much to say. And it was then sanitized to align itself to the various column heads that were available. These column heads then went on to get crystallized into more English sounding words, which are visible on the first line of the bottom right table, which has then further been sanitized into a more readable common language table, where we can now see that quality and the various quality scores have been mapped against its constituent level of alcohol, density, and other variable inputs that were a result of the physiochemical tests. Now, first things first, we needed to check if there is, if the data set has any missing values. I have used the Seaborn heat map to check that, and the Seaborn heat map here with no white marks shows that the data set as such does not have any missing values. Of course, if there were any missing values, I would have had white marks on in figure 1. For us, that's not the case. A dump check on the count, so quality versus count, and we can then crystallize that into percentages. So only about 4% of wines or wine samples in this data set carried a score of less than 5. If we then go ahead to call a score of less than 5 and assume that to be below average, then below average wines in this data set were only about 4%, while the largest percentage of wines fell into the score block of 5 and 6. So if we call the block of score 5 and 6 for quality as average, then this data set had about 82% of wines qualifying to be just about average in quality. This is a visualization of key input variables of 3 key input variables against quality. And the 3 input variables were density, residual sugar, and alcohol. For each of the input variables, we have chosen 3 types of data visualization graphs, namely the bar chart that you see in figure 8.1, the violin chart in 8.2, and the box plot in 8.3, giving us detailed description of how the data is spread. Violin chart would basically give us the spread around the mean, which is represented by the tiny white dot. And the box plot happens to be the chart where we are able to identify how many outliers or observations exist in that column, which are far away from the average values of that column. So these 3 visualizations across 3 inputs have given us various observations that are mentioned on the slide, but I will make comments on these together at the end of the presentation. This is an interesting plot. It is the LM plot, or the plot which shows the linear relationship, or if there is one, assuming there is one, linear relationship between quality and the 3 input variables that we've been discussing. And here we can see that as there is a negative relationship between density and quality, basically to say that as quality score increases, density also increases, while as quality score increases, sugar does not change as much, while there is a interesting and a significant positive correlation between quality score and alcohol levels. Somehow no surprises there. To consider a correlation between each of the input variables, frankly, this chart is the correlation plot of all variables across each other. And to say the least, I tried to use two different color palettes to decipher what it could possibly offer as information. And it offers very little or no information on comments that can be made regarding quality. Of course, there is the interrelationship between each of the variables with some number, but it is a little it is not a color map which gives out any obvious relationships, which is why the need to crystallize these input variables into common English language everyday parlance words. That brings us to the exercise of normalization and crystallization. Normalization is a tool which is used by statisticians to convert values from what they are presently to a required scale. So for example, there would have been observations under each column head. These observations under each column head would be as they were, and they may or may not conform to a particular scale. In this case, we have conducted the exercise of normalization, which is basically to say that all readings under all 11 variables of input variables have been changed from what they were to a scale of 0 to 1. Normalization will also help us add the various values of input variables so that we can crystallize them into smaller heads. Column 1 and column 2 in figure 5 will show us which variable made it to which head. So 11 input variables have made it and been crystallized into 6 heads. This is where domain knowledge also plays in, so that we can choose an appropriate title for each of the heads. Likewise, acidity, which offers sourness or offers a sour taste to wine and food, has been clubbed together with pH and called sourness. Likewise, I have chosen taste parameters as of sweet, salt, and sour. Of course, there is odor, which is sulfates, which offer smell, have been clubbed together and called odor. Density continues to remain as density. Alcohol continues to remain as alcohol. Also, because alcohol has legal limitations to it, and that there are legal bindings on beverages and their alcohol content, which has to be explicitly displayed, which is why alcohol continues to be freestanding. It is important to note that quality scores have not been normalized. They continue to stay as is from the original data set. Going further, all 11 input variables have been crystallized into 6 heads and are now being referred to as just variables. This is a visualization of what happens post-normalization. I've taken the example of pH. So for example, the pH values, the column pH values had observations which ranged from 0 to 4. And after normalization, these values have been converted to a scale of 0 to 1. Now that helps us add pH to other observations which are also on the same scale to derive meaningful conclusions. It also goes to say that the domain knowledge is important at that stage, where adding pH to, say, for example, sweetness will possibly have no sense, and which is why it is important to have the domain knowledge play in when we are doing the summation of columns. This possibly is the best case example of how normalization and crystallization can help decipher. The chart on the left hand side is a correlation between all possible input variables and has scatter plots. But these scatter plots offer lesser information regarding quality and taste. While if you look at the chart on the right hand side, we can possibly make more meaningful inferences. For example, we can say that alcohol, when compared to odor with a scatter plot which is all over the place, possibly has little or no correlation with odor. But if you compare body density and sourness, there seems to be some general positive correlation, which goes to say that an increase in body density can possibly increase, will be possibly an increase in sourness, in physiochemicals that offer sourness to wine. This chart on the right hand side first, it can be just understood as how wine at a particular quality score and its constituent physiochemical parameters or readings. On the left hand side, it's the same graph which has now been broken down into single bars and goes to represent that, for example, at quality level of 3, what would be the quality score for alcohol, so alcohol density, odor, saltiness, so on. This graph is also useful as it is a plotly graph, and at some stage we are able to actually move a cursor and check the exact values along with what that bar graph possibly represents. Coming back to the plotly graphs that we were talking, the graph on the left here represents quality scores and how each of the quality score, how each of the input variable defines that quality score. This is an interesting graph. It's a graph which basically is a graph which shows that alcohol, an increase in alcohol is directly correlated or has a huge amount of impact on the quality score. But the observations on the right hand side are overall observations from the entire discussion so far. So if we classify wine with higher quality score as good wine, we can also go ahead and say that higher level of alcohol gives good wine. It's interesting. For me, really, it was also interesting to note that both the lower scores of quality at 3 and 8 showed lesser spread of data for most observed variables. But the interesting point would be the quality score of 5, because it is that the quality score of 5, do we see a break in trend that firstly the alcohol levels have decreased for a quality score of 5, and also from previous graphs we can recollect that there were a huge amount of outliers at the quality score of 5. So for me, the quality score of 5 forms an interesting case for further analysis. This is the final profile of wine at various levels of quality, and I should take you at various levels of quality. It's again the plotly graph which helps us also move the cursor and identify the reading should we be interested. But to make broad assumptions, firstly regarding sourness, we can note that the sour factor of a wine with low quality will be higher than that with higher quality rating, which also in different words would mean that better qualities are less sour. Better qualities of wine also have a stronger odor, which is shown by the line graph that you see represented in the green line. Density does not really change much as an effect on quality. And of course, there is a strong relationship between amount of alcohol, and a higher amount of alcohol offers better quality wine. There is less or no variation in sugar, but there is sweeter wines seem to qualify for better scores, while saltiness has a minor decrease as wine quality increases. Thank you. I would love to hear from you at my personal email address. Thank you for listening to this presentation. I'd like to hear from you your comments regarding this analysis and what you think the world of wine could be like. Thank you for your time. Good day.